Please welcome Marcin.
Yeah. Okay. Hello, everyone. I hope you can hear me. Dobro utro. Dzień dobry. Thank you, Lachezar, for the initiative of that conference. My name is Marcin Szczukiewicz. A few words about me. I'm working in Nokia about 15 years with technologies, mobile technologies starting from 3G, 4G, now 5G, and probably next technologies soon. But what I have in common with the space and what Nokia has common with the space, let me tell about it as well. So I happy member of the IM2 mission by Intuitive Machines, which that Intuitive Machines is cooperating with Nokia Bell Labs and NASA, and the goal is to have a first mobile network on the moon. We will collect from the lander rovers on the moon, but this is not only experience Nokia has with space. It was mentioned also today by Axiom colleagues. Simon presented some information that we are going to integrate LTE terminals with space suites for human communications on the moon during the Artemis 3 lunar mission. So please watch the news. There will be a lot of our company soon. But okay, we started high at the moon, but now we will move toward the Earth, but we still stay in the space topics. Today I'm going to present introduction to non-terrestrial networks. So this is a technology coming from 3GPP standard. So when we think about the new releases and of mobile networks like 5G, 6G, that evolution, we more talk about about the transmission speed. So this is the main topic. Maybe a little bit about new frequencies, but that non-terrestrial network aspect is relatively poorly known. So let's change it a little bit today. I would like to introduce some terms, some architectural ideas to create dictionary for you, and which is used in mobile and satellite network industry, and I hope it will make easier to find and understand information we are reading about. So maybe let's start from the motivation, and that motivation we should start from the talking a little bit about coverage. Coverage, of course, of mobile networks. So we can consider it by population or area coverage. And when we talk about the population, which is covered by mobile network technologies, we are talking about 95% of population covered. But of course, this is for all technologies, starting from GSM up to 5G. 5G coverage is about 40% now, and of course that coverage in population is also not equal around the world. That low-income countries has about 80%. So, and that countries like in European Union even more than 95%. Second aspect is surface. So this is a opposite picture, because we have about 40% coverage of lands. So on the land there is about 30% area where the mobile signal is available. When we also add the oceans, so it is something around 10% of surface we can call that this is covered by the mobile terrestrial networks. So to fill that gap, we need something else. So this is where non-terrestrial networks can play the main role. Okay, so let's start about talking a little bit about those two words, because the current situation is that we have a 3GPP mobile, which we know very well, and everybody of us is using it, and there is a satellite SATCOM network industry, which is a second word, let's say. So those are barely connected. But yeah, a few words about how 3GPP mobile networks is constructed. We have a terminal, we have a wireless connection to the base station, so we can we can recognize where base station is looking in our landscape. We'll see antennas, and underneath antenna there is always base station. In 5G we call it G0 B. And from that base station, there's connection typically by fiber optics, but also can be by other medium, also wireless connection to core network. So let's keep it as simple as that. Satellite network. We have also terminal. We have satellite, gateway, and core network. So terminal signal is terminated at satellite. That link is called service link. From satellite to gateway there is another wireless connection. We call it feeder link. And similarly, like for terrestrial mobile networks, from gateway we have connection to some kind of core network, which is not, of course, in the same standard like core network for mobile, 3GPP. So from the user perspective, those are, like I said, two separate words. So one is for terrestrial connectivity and another is for satellite. Even worse, there is no standardization on that satellite networks, because well-known SpaceX, Starlink, or Eutelsat OneWeb has own standards, proprietary standards, which doesn't allow to interconnect, so between vendors. Of course, completely different is in that standardized 3GPP mobile networks, where we can have roaming between different partners, and from user perspective, there is no need to change terminal, even if the vendor of the service is changing. But of course, 3GPP is not sleeping, and also that industry want to change situation and standardize satellite part under some same rules as it was done for terrestrial networks. And starting from release 16 of 3GPP, there is there are recommendations and the standards for specific parts from which we can build non-terrestrial networks and integrate them with the terrestrial. In 5G, ambition is just to integrate the terrestrial networks and non-terrestrial networks. In 6G, ambition is just to unify them. So from the very beginning, standard will be optimized for both. Now for 5G, we want to have a minimum impact for terrestrial networks. But for starting from 6G, we'll think about only one network, which is composed on two parts. Okay, so this is the picture. So this is a target for 3GPP. We do not need longer to have separate terminals. Users is free to move from the areas where there is a connectivity provided by the terrestrial and non-terrestrial. That connection between terminal and satellite is called direct to handheld, direct to device, direct to cell. Different naming is used, but basic this is the same. Sometimes it is called that the direct to device is more for IoT, but anyway, from that basic, when you think about the basic rules, this is almost the same. Okay, so what kind of benefits we can expect? So that efficient satellite service for areas which are not served now. Of course, improved coverage, like it was shown on the first slide, that areas without the coverage are large, so we can improve it. Of course, it will be enhanced network resilience, and we may expect lower costs and continuous service because of common radio interface. All right, so maybe now few words what is needed, how it will work. So now I will use the terms used in 5G and 3GPP. So the terminal we call UE, so it's user terminal. Base station is called Gnode B, and interfaces for 5G. This is a new radio user interface, and there is another interface between Gnode B and core network. Is called 5G new generation interface. That architecture which I'm presenting is called transparent. Sometimes it's called also bent pipe. But we can imagine that satellite works as a mirror, but not necessarily mirrored array will be the same color, so that frequency may change. So like you see, from terminal to satellite, we can have a user interface at frequency 1, and from satellite toward NTN gateway at frequency 2. But this is still the same. This is the same interface. It has some advantages, that architecture, because payload on the satellite is quite simple. There is only frequency conversion. There's also also radio frequency amplifier, but there is no signal processing. So through all layers of 3GPP stack. So everything still is done on the Earth. So next to NTN gateway, there's a base station. That part which is in that green rectangle is some kind of frequency relay or remote radio unit functions are only implemented there. Most of the processing, all processing is done on the Earth. But the disadvantage is that there is a high latency because signal before it's processed have to go up to the satellite, down to the gateway, is processed, and then goes back to satellite and to terminal. This is the two-way communication, and because of that, we may expect lower throughput. Improved architecture we call regenerative architecture. So this time situation is like that. Gnode B is moved to the satellite. Is that payload of the satellite is Gnode B. So which performs digital processing functions as the modulation, decoding, switching, routing, coding, modulation, etc. So everything what is needed. But user interface is terminated on the satellite. So if we are talking about that, round trip time is shorter. So you can think about 2 times shorter. And that allow us to achieve a much higher throughput because of that lower latency. But disadvantage is complexity of such architecture. There is another third option because functions of Gnode B may be split in such functions like remote radio unit, like distributed unit, central unit. So some parts may be on the satellite, some maybe on the ground, but this is let's say this is still a choice of the next implementators which architecture to choose. But the most complex is that with Gnode B on the satellite, the less complex is transparent architecture. Yeah, so there is regeneration of all signals received from Earth. Okay, but single satellite is not enough when you think about the global connectivity. So we need more of them. To be honest, we need thousands of them to create constellation. As well, we need hundreds of the gateways on the Earth. So to connect 2 terminals, for example, we need such configuration. And we need something new, which was not yet shown on the diagrams. There's one another link. This is interface between 5G Gnode Bs. It exists, of course, for terrestrial networks as well. Here, that over that inter-satellite link, that XN interface is transmitted. It may be transmitted in radio technology or as a laser communication, for example. All right. So even if it seems so far a simple idea and may raise question why we do not have it yet, I will tell now a little bit about some mm, problems we may expect and complexity of the whole system. Because satellite may be operating at LEO orbit, so this is low Earth orbit, MEO orbit, so medium Earth orbit, or geostationary orbit. Of course, distances are completely different. For GEO, it's 36,000 of kilometers. For LEO, is typically hundreds of kilometers. So also all parameters like latency, footprint of the cell, of the signal, which is transmitted from a satellite, everything varies for different orbits. But orbits is not only solution for non-terrestrial networks. Standardization also consider such nodes to be located in atmosphere, so high altitude platform station, kilometers above the Earth's surface, or unmanned aerial vehicle, so much closer. So those are also options for those networks. And of course, we'll have a variety of terminals, which will have different parameters and transmission and expected throughputs and services for them will vary. So that VSAT, so very small aperture terminal, which may have antenna dish, which is tracking satellite and can have at which we can achieve very good transmission parameters. Typical handheld, let's think about a smartphone, which we have. And there's also a big expectation for IoT devices, which typically low power devices, where transmission is not so, maybe the throughput is not so high, but also the antenna zones are small, so budget of such link is very demanding. Okay, so this is only one complexity. Next complexity, which bands to choose. Like you see, for transmission, we can use different frequencies. So it was also a little bit mentioned during the presentation about the radio astronomy. The choice of the band we will use also have some drawbacks or advantages for parameters. So lower frequencies, we can expect also lower throughput. For higher antenna size, opposite is larger for lower frequencies. The last one, that attenuation is higher frequencies are more sensitive for attenuations from the atmosphere, for example. Okay, but what NTN want to use? So in the first try, frequencies are around 2 gigahertz, so very well known frequencies also from the terrestrial communications, so that the same range. So this is what G3GPP is planned in the first standards. Later, there is also plan to use higher frequencies, close to 20 gigahertz, so between 17 and 30. It is called MTN frequency range 2. For example, mentioned earlier, Starlink or OneWeb are using also frequencies above 10 gigahertz. So this is doable, of course, but standards of GPP, 3GPP, want to first try with frequencies around 2 gigahertz. Okay, more challenges. From satellite to to have a footprint of the signal on the Earth and have a transmission, we expect that between terminal and the satellite there is a line of sign. So it will be difficult to have a connectivity from inside of the buildings. So rather it is expected to have connectivity on in open areas. Mentioned earlier propagation time, which is much larger than for the terrestrial networks, is few times larger. It's not a huge drawback. Still, we can manage such propagation time to have a good quality services. But of course, there is some kind of limitation. Mentioned also attenuations, for example, from atmosphere, like clouds, but also ionosphere, buildings. Elevation angle. Because cells operated by satellites are much higher than those operated from the Earth, there's a big variety of the parameters depending on where user is located. So just underneath the satellite, there is a shorter path, of course. Angle is 90%. At the edge of the footprint, signal footprint, of course, there is a lower angle, much larger distance. So this is a challenge as well for that technology. And we'll have elliptical beams. So let's imagine like we have a torch in the hand. So when we are putting light vertically on the floor, we have a circle. But when we keep torch at some angle, we'll see elliptical shape on the floor. So it's the same with the signal of the shape of that cells from the satellite, and it is also causing some problems for technology. That is interesting because everything is moving in that non-terrestrial communication. Satellite is moving user is moving, but also cells are moving, because there are two types of cells which are proposed by 3GPP: fixed Earth cells and moving cells. But for low Earth orbit, so LEO orbit, we may expect that cells will be moving, so that moving cells will be chosen, and it causes a lot of challenges for technology, because of, for example, Doppler shifts. So everybody knows that the Doppler effect, when signal is object is approaching with some kind of signal, we have a higher frequencies than nominal. When is going away, we have lower than nominal. And here, if satellite is moving thousands of kilometers per second, this is really challenging to play with Doppler shifts. Please imagine also those frequent and massive handovers, because if cell is moving, everyone who has service in one sector will jump soon in another sector, and another and another. So handovers are not because of movement of the user and its equipment, but because of the movement of satellite. Another problems: inter-satellite links and networking. So with the thousands of satellites over the Earth, routing such signals, connecting, optimizing that network will be very challenging, and we can expect a lot of ideas in that area. Of course, like I said, also different mediums used, like optical laser or radio may be used. Another is policy and regulations. So if cell is moving, it's moving also across borders. So at some places, some frequencies may be used, and that signal cannot be then propagated there. It may be limited, just some countries may not allow to have a signal from satellite. So etc. etc. Also, such regulations like light pollution. Another, because of thousands of satellites on the orbit, we may expect that very often. So in day span, we may expect that some satellites will be deorbited. So and every few weeks, we'll send another ones to replace them. So such a busy environment may cause additional problems in the policies and regulations. Okay, but we as technical people, we always try to find the solutions, even if there are challenges are difficult. And we have first success stories. So, for example, Nokia and US Space Mobile had a common mission that US Space Mobile, where Nokia's RAN technology was used, and there was connectivity from space to 5G smartphones. So AST sent huge array, antenna array to space, and that was used to for that transparent architecture with Nokia's front technology. And what next? The European agency, space agency, is also very interested and investing a lot to that technology. European standardization SCP also is interested in that technology and trying to have impact on the standards. So, like I said at the beginning, maybe if we are talking about 5G and 6G, mainly about the speeds, throughputs, and new frequencies used, that non-terrestrial network is really also big part of those generations of mobile networks. So if you are a student, because we are at the technical university, a lot of master theses may be done about NTN soon. So covering its technological solutions and challenges. A lot of code will be written soon, electronics made. So the future is now. So please pay attention to that topic. A lot of interesting news will come soon. Okay. Now, questions and answers. Do we have any?
Yes, we do have one. Just a second.
Thank you for the presentation. My question is about multi-orbit connectivity. What are your thoughts on this? Because it's mostly proposed by, companies that have been, let's say, providing service over geo. So what are your thoughts on this? Do you think it's something that's, let's say, has a lot of future, or it's mostly like an adaptive, let's say, mechanism by the older connectivity providers? Thank you.
I'm sorry, I didn't hear the beginning of the question.
Maybe he can repeat it. Just a second.
Yeah, just your thoughts on multi-orbit connectivity.
Yes. I don't know. Like I said, this is standard. Like you see, there is not yet implemented. So we can, those implementations are tries. Of course, it's completely different, like SpaceX or Eutelsat did with OneWeb or Starlink. But I'm sure that there is, of course, in standard there is a room for inter-orbit connectivity. So every orbit can be used for specific purposes. So probably also it will be a part of the work. I don't know how big priority it is, but there is a possibility. It is standardized, so probably sooner or later it will be part of the engineering work.
Okay, we have another question. Just a second. I need to reach the person. This is a good time to say thank you for participating again in this edition of the conference. I hope to see you soon live, though, and to have a beer or two together.
Okay.
Do you have an average or some far estimate on what is the usage of base stations and the spectrum,
But
like
in,
percent use?
I didn't understood. Could you please be more?
So the core network So assume that all resources on the core network are in use, that's 100%, and then nobody is using it, or then maybe a few users. So that's between 0 and 100%. And then also the spectrum of mobile networks in general, if you have any idea.
Oh, I do not have such data. So,
Okay.
sorry.
Thanks.
Any other questions? Yep, we have one more. Just a second.
My question is more when it comes to like feasibility in terms of people participating in this. As you stated in the beginning, there is an issue with, for example, Starlink only allowing for its own terminal to be connected to it. What is the current state of, what is the current attitude of the space companies, especially that are producing these satellites, in terms of actually allowing for and pushing for standardization of the connections, especially for 5 and 6G? And also, what are the institutions that are trying to work on this issue? Is it the International Telecommunications Union that is mostly in work here? How is the process of this standardization happening? Thank you.
Okay, so I showed standard, let's start from that. I showed standard release 16 of 3GPP. There is already release 17, 18, 19. So if basics were in release 16, there's a lot of done also for the next standards. And in all of the standards, participation is, of course, by universities, by that institutions, like you said, international telecommunication unions and similar space agencies as well, and main players like big operators and telecom companies like Nokia. So I encourage you to just write it in any browser you have, and you will see how many informations about the non-terrestrial networks, and you will see also who is writing those articles. So there's a big noise, maybe only limited to that people who are interested in it, but there are really big players engaged in the technology. What about the SpaceX and how they see it, or operators? I don't know. This is a business, and the business part soon want to see probably the income, and if that income will be with high probability, then we'll see the first releases as well.
Any other questions? Okay, I think that's it. Again, thank you, Marcin. A round of applause for Marcin. Thank you again for participating, and we'll keep in touch.
Okay. Благодарим ви. Bye.
Good job. Bye-bye.
Bye.